we're going to carry on through our 3.2 notes. We've done sine law. You were given lots of triangles and you were able to solve sine law. You even got into some word problems. In the senior classes, we call them applications instead of word problems. But any application is really applying it to real life, which turns out to be a word problem anyway. So we're kind of like trying to hide word problems from you in the application center. Okay? Now, we're starting off with an easier one, but then we're going to move into ones where you have to draw the diagrams. And I'm going to be very specific. You really need to draw out diagrams to make them work for you. Okay? So in our first example, Toby uses chains attached to hooks on the ceiling and a winch to lift engines at his father's garage. The chains, the winch, and the ceiling are arranged as shown. Toby solved the triangle using the sine law to determine the angle that each chain makes with the ceiling to the nearest degree. He claims that angle theta is 40 and angle alpha is 54 degrees. Is he correct? Explain and make any necessary corrections. Good. So once you're given a diagram, you can label this triangle ABC anyhow you want. So let's do that first. So I'll label this A, this B, and this C. Now, when I look at this, I'm given this angle and this side length. That really works for us in sine law, right? Because one of the key things in sine law, you guys, one of the key things in sine law is that you have an angle and a side length across from each other, right? And now we can solve for angle theta or for alpha. Okay, which one do you want to do? Alpha here? Okay. Oh, you're doing side A. Okay, so angle alpha, which is angle B, right? So whenever I set it up, I'll go side length C over sine C is equal to side length B over sine B. Are you guys okay with looking at a diagram and actually pulling out sine law now? You think you could do that for sure? Good. That's half the trouble with these applications. The other half is to draw the diagram, okay? So, what's side length C? Jesse, what's side length C? 2.8. And angle C? Angle C, Dylan says it's 86, so sine of 86 is equal to side length B. Do we have a side length B, Jocelyn? (1.9) over sine of B. Okay. So now I'm just going to cross multiply and solve. I didn't pull up a calculator. Sorry, guys. Maybe you guys can help me out. We go what? 1.9 times the sine of 86 is equal to 2.8 times the sine of B. How did I shift from here to here? What did I have to do? Demare, how did I shift from this step down to this step? Just cross multiplied. So I could divide by 2.8, right, on both sides as well. And I get sine B is equal to something. So all you're going to do is you're going to type in 1.9 times the sine of 86, hit enter or end bracket, divided by 2.8, gives you 0.676. How do you find angle B then? We just second sine. Which will give me 42.6, which rounds to 43, right? So that's angle alpha, and he had it as 54, so he must have done something completely off. Okay? So B is equal to 43 degrees. which is really angle alpha up here. Now, we could do sine law again and solve for theta. Or as Reese is in the back here saying 180 minus 86 minus 43 to get us angle theta to be 51 degrees. Okay? Is this okay? Good. This is half the battle, knowing how to use sine law. We didn't have to do diagrams, right? The diagram was set up for us. Our next example, okay? Our next example does not have a triangle for us. We have to set it up, okay? I think we might be able to set this up, but I want everyone to be paying attention because this is probably one of the hardest parts in this whole unit, is to be able to draw these diagrams. We'll use this again in Physics 30 to tell you the truth. Okay? So a captain of a small boat is delivering supplies to 2 lighthouses. As shown, his compass indicates that the lighthouse to his left is located north 30 degrees west, and the lighthouse to his right is located north 50 degrees east. Determine the compass direction he must follow when he leaves lighthouse B for lighthouse A. Okay? So when I look at this, they're all north. So I'm going to say we have a lighthouse here, and we have a lighthouse here, and this is where his little boat is. Okay? You like my boat picture? So we can see this triangle in here, right? You guys see that triangle there? Now, how do we come up with angles? Good. Do you know what north 30 degrees west means? Good. So what that means to me is you need to have a never eat shredded wheat kind of sign here, right? North and then 30 degrees east, right? So from the north line is 30 degrees east, okay? So north 30 degrees east, that's just 30 degrees right there. That's all it is. Now, the other side is north 50 degrees. No, oh, sorry. Never eat shredded wheat. So west is that way. So north 30 degrees west. Let's erase this and get this straight. West is that way, right? Never eat shredded wheat. So it should be north 30 degrees that way. And then the other side is north 50 degrees east. So this side is 50. So this whole angle in the bottom is 80 degrees. Okay? That whole angle in the bottom. Now it says, determine the compass direction he must follow when he leaves lighthouse B for lighthouse A. So his compass indicates his left, north. So this must be lighthouse A over here. And this must be lighthouse B over here. Now, if I draw this never eat shredded wheat kind of sign here, we have east-west lines which run parallel. You see the lines that are running parallel now? East-west parallel, east-west parallel. So if this angle to the north, if we extend this, is 50, this angle up there is 50. We'll get there though, okay? What? Perfect. We'll get there.
How do you know how far away A and B are?